Welcome to another episode and video on my Arduino Mega2560 right here, which is connected to the Arduino Uno through SPI and I2C. This is the SPI connection and this is the I2C connection, much less visible but nevertheless quite well working. Connected to breadboard with electronics, here a little bit, there most, with fischertechnik mechatronics. This one is connected to the Uno, this one, and these two are connected to the Mega2560. Last time I changed the algorithm so that pulse modulation for this one now works correctly on the Uno side. It turned out that I had to remove them from the I2C routine because that just did not work, and that was completely correct. So now that works, and at the same time I'm in a more or less solved a problem on delay. So yeah, there was a problem on what to use. Timeout in milliseconds or delay, and delay just works for the whole system. So that one is mostly solved. What is not solved, as you can see, is this one, because this wiring should be not here but in the lane next to it, but that doesn't work. So that is a problem. Another problem is, of course, that these don't work. And while these circuits do work, and you can see that because of the LEDs, but the motors absolutely do not. And this wire was intended to make contact to this resistor, and then it should work, kind of. But that's not working, and so I'm still at the loss. Why it doesn't work? Primarily because those two in design cooperate with these switches. This one with this one and this one with this. So they do work, and upon touching the switch they briefly stop and then go on. Well, that hasn't happened for a long time. So while I continue to see a use for I2C and the Uno, for this time I wish to concentrate on pulse modulation with switches, and in comes also the Uno with this one, because that is an odd one as well. So let's see how far we can get. So, as I said, concentrating on pulse modulation for these two motors. Now I have hooked up the two resting other probes. This one is connected to this motor, and this signal is connected to this motor. And for explanation I have to get this one. So where does it all come from? Motor with propeller, motor with propeller. and that's quite different. This one has one inductor, wire inductor, resistor inductor, and this one has no less than 3 of them. Looking at this one, the pulse modulation is completely different. Why is it different? Let's see the code. By the way, this is port 2 and this is port 4. So I'll have to look at that. Not that way. This way. 2 and 4. And this is the way it is set up. Pin 2 and pin 2 has 120 Hz and the other one something. Oh, the other one also. So why aren't they the same? Oh, and that's another one. On one of my other projects, these values have gotten now the values of the pins. Now, how about this one? See? These are very different values. These are the actual values. So, output 2. And not output value, but output. Analog out pin 2 gets output value 1. So it doesn't even get output analog out pin 2. It gets just a different, it gets a sensor value. But it is the way it works. And here's the other one. And they have both the same value. And now one thing is, of course, how do I read which one it is? Which one is which? I don't actually. So I should say that, and that is of course important right now, that I on screen show which port is which, is publishing which. Now I do that with analog out pin 6, but I don't. Not that I can, yeah, here I see it. Analog out pin propeller. So here I do. Do I do it here as well? Analog out pin 2 propeller. Yes, I do. But I don't do it for 4, I think. No, only for, why do I do it for 6? Is it not in 4 but in 6? I'll have to check that. Four is connected and 6 is connected. And 6 goes to one motor, yes. and 4 goes to is headed to this motor. And then it helps when I actually show it. So 4 is connected to this motor. To which is the other motor connected then? Oh, I'm wrong by the way. Let me probe a wire. Yes, I was wrong. No, I'm still right. 6 is connected to this motor. And the other one doesn't matter right now. Anyway, I need to check on that. So why did I put 6 here? Because of this. So I need to copy it. And make this 4. And then I know for sure which is which. So for now, checking the correct board, checking the correct port, and most importantly, kill it. And in this case it is for 0, 28, 314 and 28, 315. Terminated, that's good. So I can upload. Which is strange now. Because this motor is connected to the Mega2560 and it didn't stop running. Whereas this motor, this one, did stop running. So why that is beyond me for now. Anyway, it's uploaded. Let's check. That's all we can do. So now with the new software, let's check. And I have to start screen again. I2C works nicely. And then SPI still working, very good. See, they have exactly the same value, while this is different, and this will be different because of the difference with the circuits. So let me change this. And I will put the probes somewhere else, where there is no hassle with the signals. Let me check on that one. So this is one where it comes in. And this is the other one where it comes in. what is the difference? There really should be difference. Watching the oscilloscope signal goes flat, and then there's signal from I2C, and right now I'm probing here, so I'm probing here and I'm probing here. So on these two highlighted spots I'm probing. So you would expect that anything goes right? 4 and 6, now 248. And by the way, the motors are still not doing anything. Not by a long shot. So there may be something else wrong as well. But I'm not quite sure what. Let me rewire the motors then, and for shortly put them straight in front of the transistor right here. And of course this is not correct or entirely correct wiring. I should use other wires by now. I have plenty. So perhaps a very good time to actually rewire. I think that's a very good plan actually. Yeah, well, at least this is a working one. So yes, a very good idea to completely rewire. Make them real wires. Yeah, that's a very good idea right now. So now I have obviously changed the wiring, as you can see, much robuster, much more robust, whatever. But does it work? Well, this circuit for sure does not yet, which is strange. Considering the fact that the circuit does work. So if I change this wire and put it, well, let's just wire correct, twist it. Then something should work. But this is obviously not the idea. Now, will this work the same way for the other motor? And and then I notice that I have not enough space between the wiring and transistor, so I'll have to put it right okay. In comes a plier. Now let's see if the other motor wishes to cooperate. And the answer is a very obvious no, it does not cooperate at all. So which one is which? The dark blue one on the bottom, this one, is then not able to drive this motor, while the smaller motor obviously is working. Ouch. So, which drives which? That is a very good question. I'll have to go to the code again and see which one does which. Sensor value, analog in pin. Right, analog in pin. Yeah, and it's been quite a while since I've been doing this. Is a 0. That is good. A 0. Where's A0 again? Right there. Okay. So it is. Okay, let's get the camera with it again. I have to go right there to this potmeter, which is right here, to change the value. So let me see if I can get it done. Oh, look at that. That is a very different value on the oscilloscope, but also complete motor stop. And now it starts again. So how about this potmeter? And let's check again. Oops. That stops this motor and no particular effect on anything else. Okay, so I am turning the potmeter just very little, but the effect is enormous. It's either on, it's either off or on, and when on it gives a massive speed. And with this one it is more or less the same. So let's do it again. And yes, I'm blocking the whole thing in with the light. watch the oscilloscope as well. Okay, now this motor is now running very slowly and now fast. And now I have to change the other one again. Alright. And I better do it with this stuff. So now it's 252 and everything is 252. Let's wait for it. This takes a long time. And double. So what is this one doing? Look at the oscilloscope, it's nearly on all the time. Okay, end of the voltmeter. But I don't see any change on the value. Not anymore. What has gone wrong then? Nothing here. Oh, it's terminated. And keeps terminating. Screen is terminating. Wow. What's wrong here? Okay. I don't have a screen zero. Then I think I should terminate the whole screen stuff. That will be 318, 28, 319. All done. Okay. So go. Oops, terminating. Go. That means that I have a slight problem. So let me turn it up. Hopefully that works. Wait for the oscilloscope signal. Nope. Turn the other way. Okay, that was too much. But I can't see anything on the... So let's see the terminal. And yes, that doesn't work. Screen is terminating. Not good. Not good at all. And with that I have come to the end of this episode, where it shows that things don't always go right no matter what you do, and that at times Murphy jumps in and doesn't want to leave. So anyway, thank you for watching, because time is up. If you like this video, please subscribe to my channel. Give the video a thumbs up. and leave a comment if you like. You can also follow me on Instagram. If you do, please like and leave a comment. You can also, I have also Instagram TV with short videos. You can also follow me on Twitter. Please, if you do, retweet, like and leave a comment. You can show your support, very much appreciated, by if you make a little donation. You can also choose to become a patron and have your name mentioned as a supporter. Your name will be mentioned on my website as well as with my videos, depending on the pledge you make. And this is obviously going to be continued. Thank you for watching and bye bye.